Download this code from codegive.com, link in the description below. OK, let's dive into the fascinating, and often frustrating, world of handling loading failures at boat ramps. This tutorial will cover the fundamental concepts, common causes, and a C code example demonstrating a robust approach to dealing with potential issues. Boat ramp loading fails, Part 1. Understanding the problem and designing a solution. What exactly constitutes a boat ramp loading fail? The term boat ramp loading fail is used humorously, and sometimes not so humorously, to describe a variety of problems encountered when attempting to load a boat onto a trailer at a boat ramp. While the potential for physical mishaps and equipment damage exists, we will focus on the data loading analogy. In a programming context, we're talking about scenarios where we intend to load data from a persistent source, example a file, a database, a web service, to populate a data structure, class object, or user interface within our application, but something goes wrong during that process. This loading can fail for many reasons. Data corruption. The data source might be damaged or contain invalid information. Network connectivity issues. If loading data from a remote server, the connection could be interrupted. Invalid format. The data is in an unexpected format, example trying to parse JSON when the file contains XML. Resource constraints. The application might run out of memory while loading a large data set. Permission errors. The application might lack the necessary permissions to access the data source. Database errors. Problems such as connection timeouts, incorrect credentials, or queries returning unexpected data. Concurrency issues. Multiple parts of the application trying to access or modify the data source simultaneously. 2. Why robust error handling is crucial. Failing to handle loading errors gracefully can have serious consequences. Application crashes. An unhandled exception can terminate the application, leading to data loss and user frustration. Data integrity issues. Partially loaded or corrupted data can lead to incorrect calculations, inconsistent states, and ultimately, incorrect decisions made by the application. Security vulnerabilities. Poor error handling can sometimes expose sensitive information or make the application vulnerable to attacks. Poor user experience. A cryptic error message or a frozen UI can leave users confused and frustrated. 3. Designing for resilience, key considerations. Before diving into code, let's consider the core design principles for handling loading failures effectively. 1. Anticipate potential errors. Identify the possible failure points in your data loading process. Consider the types of errors that are most likely to occur, and what could cause them. 2. Use exception handling. Wrap your data loading code in try-catch blocks to gracefully handle exceptions that might be thrown. 3. Log errors. Log all errors that occur during the loading process. This provides valuable information for debugging and troubleshooting. Include the timestamp, error message, and any relevant context, example file path, database query. 4. Provide informative user feedback. Display meaningful error messages to the user. Avoid technical jargon and explain the problem in a way that they can understand. If possible, suggest possible solutions or workarounds. 5. Implement retry mechanisms. For transient errors, example network connectivity issues, consider implementing a retry mechanism. The application can attempt to reload the data after a short delay. Be careful to avoid infinite loops by setting a maximum number of retries. 6. Roll back or clean up. If the data loading process involves multiple steps, and one step fails, consider rolling back any changes that were made before the error occurred. This ensures that the application remains in a consistent state. Clean up resources that were allocated during the loading process, example close files, release database connections. 7. Configuration and dependency management ** externalize configuration settings, example database connection strings, file paths, so that they can be easily modified without recompiling the application. Use dependency injection to easily switch between different implementations and test the data loading logic in isolation. 8. Asynchronous operations ** if loading large data sets, use asynchronous operations to prevent blocking the main UI thread. This ensures that the application remains responsive during the loading process. 4. C code example, loading boat data from a file. Let's create a simple C example that demonstrates how to load boat data from a file and handle potential loading errors. Assume we have a file called boats.csv that contains comma-separated values representing boat information. Here's the C code. Explanation *. One boat class * represents a single boat with properties for its ID, name, length, beam, and engine type. To string is overwritten for easy display. 2. Boatloader class * encapsulates the logic for loading boats from a file. File path * stores the path to the CSV file. Load boats method * this method attempts to load the boat data. It's wrapped in a try catch block to handle potential exceptions. 3. Error handling * file not found exception * checks if the file exists before attempting to open it. Throws an exception if the file is not found. IO exception * handles errors that might occur while reading the file, example file is locked, permissions issues. Format exception * handles errors that might occur when parsing the data, example a value is not a number. General exception * catches any other unexpected exceptions. 4. Data parsing *. The code reads the file line by line, splits each line into an array of values using the comma as a delimiter. It then attempts to parse the values and create a boat object. 5. Logging and user feedback *. The code uses console.write to log error messages to the console. In a real-world application, you would likely use a more sophisticated logging framework, example nlog, Serolog. The error messages are designed to be informative and helpful. They include the file path, the line number where the error occurred, and the details of the exception. 6. Skipping invalid rows *. If a row has the wrong number of columns or causes a parsing error, a warning message is displayed to the console and the parsing continues with the next row. This will prevent a single incorrect row from halting the entire import process. 7. File header handling * skips the first line, which is assumed to be the header of the CSV file. Example usage. 1. Create a file named boats.csv in the same directory as your C code. Populate it with some boat data, or use the example data above. 2. Run the C code. 3. The code will attempt to load the boat data from the file. If any errors occur, they will be logged to the console. 4. The loaded boat data will be printed to the console. 6. Part 1 Summary. This tutorial provided a foundation for handling loading failures in C. We covered the importance of error handling, key design considerations, and a practical example of loading boat data from a file with comprehensive error handling. The example demonstrates how to use try, catch blocks, log errors, provide informative user feedback, and handle different types of exceptions. This ensures that the application is robust and resilient to data loading errors. In Part 2, we'll delve into more advanced topics. Implementing retry mechanisms. Asterisk handling database connection errors. Asterisk using dependency injection for testability. Asterisk implementing rollback and cleanup strategies. Asterisk asynchronous data loading. This will give you a more complete picture of how to handle data loading failures in a real-world application.